Hello everyone. Let us now discuss how can we solve this problem. Find closest node to given two nodes. So as I say that we can solve this using a BFS or also a DFS algorithm. We just need to know what's the distances and also how to get the minimum distance and also return the index. Now, let us see by going through the question first. You are given a directed graph of n nodes numbered from 0 to n minus 1. Now, where each node has at most one outgoing edge. That means every node has only one outgoing edge, right? Either it can have an outgoing edge or not. It don't have any outgoing edge. Now, the graph is represented with a zero indexed uh, edges of size n. That means here we are only given with edges, right? Now, indicating that there is a directed edge from node I to node edges of I. If there is no outgoing edge from I, then edges of I is equal to minus 1. Now, whether like if I have a 0 and if I have a 1, what does that mean? There is a node from 0 to 1, and if I have 1 I have 3. What does it mean? The node from 1 is having a directed edge from 1 to 3. Now if I have 2, then if I have a 1 here, then the node 0 is having a edge from node 2 is having edge from node 2 to node 1. Okay, now if I have 3, there is minus 1. That means there is no outgoing edge from node 3. You are also given two integers, node 1 and node 2. So we are given with node 1 and node 2. Let's see what we need to do with these two nodes. Return the index of the node that can be reached from both node 1 and node 2, such that the maximum between the distance from node 1 to that node and from node 2 to that node is minimized. If there are multiple answers, return the node with the smallest index, and if no possible answer exists, return minus 1. Now, let's see how we can just understand this statement. Return the index of something like that. Now, let me take some nodes D1, D2, D3, and I have node 1 and node 2. Now the answer is initially minus 1, and the distance from node 1 to node 2 and node 1 to distance 1, D1 destination 1, and node 2 to destination 1 is something like it is 5 and it is 3, and from node 2 to destination 3 and node 1 to destination 3 is something like 4 8 with some nodes, right? Now let us see what happens here actually. Node 1 to destination 2 is something like 10, and node 2 to destination 2 is something like 15. Now let us see. What are they asking? Such that the maximum between the distance from node 1 to that node 1 to destination node, and from node 2 to that destination node, the maximum distance between these two distances is minimized. So if I take the maximum of the distance from node 1 to destination node and node 2 to destination node, this should be minimized. Now the destination can be any node, and we need to return that destination node. Now let us see. Let us see by taking D1. D1, instead I am naming it as 1, node 1, node 2 and node 3. Now let us see. The n1 to the node 1 is 5. N1 to node 1 is 5. N2 to node 1 is 3. Okay. Now, the maximum of these two distances is 5. Okay, for now I got 5. Now, I have another destination node. Node 1 to destination 3 is the distance is 8, and the node 1 node 2 to destination 3, that means node 3 is having a distance of 4. Okay, the maximum from these is 8. Now node 1 to destination 2 is 10, the distance is 10. Node 2 to destination 2, or node 2, this node index 2 is 15. Now the maximum from these two is 10. Now from all these we need to return the minimum distance. And where did I get that minimum distance? Which node did I get this minimum distance? I got this at node 1, index 1. So we will return 1. Now let us just go ahead and take another node, right? Another node. I am taking this node 4, and it is having the maximum, like the distance of this is 5 and then this is 2. Now the distance from n1 to node 4 is 2. Let us take this also, is 2, and the distance from n2 to node 4, n2 to node 4 with some edges is 5. Now it is 5. The maximum of these two is 5. But what we need to return in this? I got this with node 1. I got this with node 3. I got this with node 2. I got this with node 4. As they mentioned, if there are multiple answers, return the node with the smallest index. If no possible answer exists, return -1. Now, so what I need to return? I need to return node 1. Just let me be clear that we need not to return, we should not return the distance. We need to return the index of the destination node. Now, let us just look at these examples, these kindergarten examples, right? From node 0, we can go to node 2. Okay, node 2. And from node 1, we can go to node 2. And also from node 2, we can go to node 3. Now, the nodes which we are given with are node 0 and node 1. This is n1 and this is n2. Now, as we did in the previous problem, here in these all, let us take all the destinations node, right? Here I have node. This is node 1, and this is node 2. Okay. Now, I have this node and this node. Let me name node 2 as D1. The destination 1 node is just 2. Now, the maximum distance to reach node 2 from node 0, which is n1, from node 1, which is n2, is just 1, right? Is just 1. Is just 1. So, maximum from 1 comma 1 is just 1. Now, let me just take another destination nodes 2. I'll get to that. Now, here node 3. D2 is node 3. Now, the maximum from uh, reaching from node 0 to node 3 is 2. From node 1 to node 3 is also 2. Is 2, and then it is 2, and the maximum between these two is 2. Now, I can also make this as destination node, right? If I start with this node and the distance to get to that node from node 0 node is just 0. Now let us take that. Destination 3 is 0. Now to reach from n1, which is 0 to 0, is just 0. Now to reach from 1 to 0 is just 2, and the maximum from these two is 2. Now let us take another destination node, which is 1. To reach from 0 to 2, is there any choice? Right? I can go from here to here. Let me remove all these things. Firstly, right, I can reach from 0 to 2, but I can't reach from 2 to 1, so it cannot be possible, right? So the minimum from all these, the minimum from all these is 1, and I got that by taking 2 as the destination node. So I'll return 2 as my answer. Now let us do the same thing here. Let me take all the destination nodes D1, D2, D3. D1 is 0, D2 is 1, D3 is 2, and a maximum of 2 nodes, right? Maximum of 2 distances. Maximum of 2 distances. Now let us see. So we are starting from 0 and 2, right? From 0, the destination is 0. So 0 to 0, the distance is 0. From 0, the destination is, from 2, the destination is 0. Can I reach 0 from starting with 2? No. So minus 1. So here I can't reach. I cannot even get the distance. The destination 2 is 1. From 0, can I reach 1? Yes. So if I reach from 0 to 1, then the distance is 1. From 2, can I reach 1? No. I cannot reach, right? So I can't reach. From 2. So the destination node is 2. From 0, can I reach 2? Yes, with a distance of 2. Now from 2, can I reach 2? Yes. So the maximum of 2 comma 0 is 2, and from all this the minimum is 2. So we'll be returning 2 as our answer. Now what I need is taking destination nodes every time, right? So I will I will get the distances from n1, which is given with node 1 and node 2 to every node, right? And I should not exclude n1 and also n2, right? Now let me just make that into a vectors, and this is something like a vectors which stores in distance 1 and distance 2, and let me get this maximum from all this. Now my answer will be minus 1. Now I have distance 1 vector and distance 2 vector. What does this mean? Is this will be the distance to get to this node index I from n1 here, from n1 here, from n2. So let me write it over here. Distance 1 of I stores the length or distance to meet node I starting from node 1. That means node 1. Okay. Distance 2 of I stores the length or distance to meet node node I node I starting from node 2. Let me name it as n1 and n2. Okay. Now they are storing the same thing which I stored here, right? So what I am doing, I'm getting the maximum and taking that into something, and I am getting the maximum from this, and I am returning the minimum from all of them. But the minimum where I got this minimum, and that destination node, sorry, here we will be returning to, sorry for the mistakes. So the destination node will be returned. Okay, sorry. Now let us take answer is equal to minus 1. For int I is equal to 0 to n, let us see if, let us just take the max distance is equal to maximum of distance 1 of I comma distance 2 of I. So now before that let us take the minimum distance, and the minimum distance will be infinite. Now if maximum distance is lesser than minimum distance, then what I will do is minimum distance is equal to maximum distance, and answer is equal to I. That's it. At the last we'll be returning the answer, the index where we can reach, right? So this is the intuition for the problem. Now, how do we get actually the distances, right? We'll be using a BFS, or also we can use a DFS for this. Now, in the main problem, that means the main function, we'll be doing firstly distance 1 vector and also distance 2 vector. Now, from every node, we can reach only one node, at most one node. In the BFS and DFS, we no need to go through neighbors function, something like neighbors, right? We can just go to edges of node. This will help us, right? Now we have distance 1 and distance 2. What I'll do is just start BFS or DFS with distance 1, and we have given with edges, and the starting node is 0, right? So we can use that BFS or DFS algorithm here, and we got the distance 1 and distance 2 here. Now we just simply get this minimum distance is equal to infinity and all of this to here, right? We'll just take it from here to here and just paste it over here so that you can understand how we can get the answer, right? So here we'll be given with answer is equal to -1, and we have minimum distance is equal to infinity. That means int max, right? And also we are not missing anything. Now let us just see how we can go through the BFS first. Now what I'll do is just make a visited array right here, a visited array for the BFS, right? And comma false. Now we'll be storing a distance array and everything with -1 with the size of n. Now how does this BFS algorithm look like? There will be a starting node, there will be a visited node, a visited array and edges array. And is there anything else? Let us just go through with it. Now we'll be initializing a queue of int and queue dot push the starting node, and visited of start is equal to true. Now let us go. While queue is not empty, we'll be doing something, right? Int node is equal to queue dot front and then queue dot pop. Now we'll be having neighbors. No, we are just having int neighbor, or let us just take, yeah, we'll be having neighbor is equal to edges of node. This is the only neighbor, right? So if distance of neighbor, here we need to also get the distance of neighbor is not equal to, sorry, is equal to -1, and visited of neighbor is false, right? Now if it is false, then distance of neighbor is equal to distance of node plus 1, right? And then we'll be pushing this q dot push neighbor. That's it. This is how you get the distances with BFS algorithm. Now in the DFS algorithm, it is quite simple. Taking the same parameters, just we need to return with the length, or let me name it as depth, right? DFS of depth plus 1 and everything as simple distance, and also there will be nothing like anything visited array. We'll be using distance array, and also we'll be having edges, and we'll be having node. Okay, we'll be having node. Now depth is increased, and then here we'll be having distance of node is equal to depth. So we'll be starting the depth. When we call this DFS function, we'll be calling with 0 in the main function. I think it is clear, and I have given the code links for BFS and DFS in the description. And if you like this explanation, do like, share and subscribe to my channel. And if you have any doubts, you can comment in the comment section. I will reply. So thank you for watching this video.